Hello, this is question 16 on your AQA paper 1 from November 2020. It's a mechanics question, a connected particle question. So you have a simple lifting mechanism comprises a light and extensible wire which is passed over a smooth pulley. So this is the pulley, this is the wire. One end you have a triangular container which is 2 kilograms and it has inside a mass, a load, of m kilograms. At the other end, you have a mass of 5 kilograms, and the mechanism is initially held at rest, as it's shown in the diagram. The mechanism is released from rest, and the container begins to move upwards with acceleration a. So when this is released from rest, this is going down, this is going up, and the acceleration, they say, is a. So this is going up, acceleration A, this is going down, acceleration A. The y remains taut through the motion, right? Then the first thing they ask is show that the acceleration is this expression here in terms of m and g. So the first we are going to do is to draw the forces that are acting in both masses. So in this one, on the right hand side, I'm going to have a tension pointing up and a weight, which is going to be the mass, which is 5 times g. And then in the other one, I'm going to call this, for example, A, and this one B. And in A, I have a tension pointing up, which is the same, pulley smooth, and this one pointing down is the total mass, which is 2 plus m g. If I want to find the acceleration, what I'm going to do is to write an equation of motion for this one and an equation of motion for this one, eliminate t, and find a in terms of m. So for a, my equation of motion is, so for a is going up, so a is this one is going up, that means this one is greater than this one, so the resultant force is t minus this. So t minus 2 plus mg is going to be mass, which is 2 plus m times acceleration. And for b is this one is going down, so 5g is going to be greater than t. My resultant force is 5g minus t. So for b, 5g minus t is the mass, which is 5 times acceleration, which is the same than the other one. I'm just doing, for this, force is mass acceleration, The equation of motion comes from this. Force, resultant force is mass acceleration. So here I have two equations with two unknowns, a and t, And I need a, so I'm going to eliminate t. And to eliminate t, easily I can just, for example, add the equations, because I have one t and 1 minus t that are going to go, and then I have 5g minus 2, I'm going to expand this bracket, so minus 2g minus mg is going to be this plus this, so I have 2a here plus 5a here is 7a plus ma. And well, actually, I could do that. So my acceleration is going to be all this, which is 3g minus mg, so 3g minus mg divided by, I can factorize this with a times 7 plus m in the bracket, so I'm going to divide by 7 plus m, which is the expression that I have to prove. I just have g outside, so I have factorized the numerator. So I have 3 minus m divided by 7 plus m, or m plus 7 times g, which is what we needed to prove, which is this expression here. Then for b, I have to state the range of possible values of m. So m is this mass here. If this is 5, and this is going up because this is heavier, the total mass of this thing must be smaller than 5, so it can move up. It can move up, otherwise it wouldn't move. So this whole thing has to be smaller than 5 to be lifted. So 2 plus m 2 plus m must be smaller than 5, which means that m must be smaller than 3. And probably that could be enough because it's just 1 mark, but I would say mass has to be positive or 0. So you can write that m could be at least between 0 and 3. Yeah, they don't say anywhere that it's positive or greater than 0. It just says, it wouldn't make sense that it's 0, but it still would be a possibility, I suppose. Yeah. Then the next part is you have to use G 9.8 and the load reaches a height of 2 meters above the ground 1 second after it's released. We need to find the mass of the load. So after 1 second, this whole thing has moved up 2 meters. We have distance and time. So this is going to be a Subat equation question because we have constant acceleration, which is the one that we just found. So this one here, this acceleration is in terms of m, but it's going to help us. So it's going to be a Subat equation question. So I'm going to write Subat this way. I know the displacement is 2 meters. Initial velocity is 0 because it's released from rest. We don't need the velocity. The acceleration is, we say 3 minus m. 3 minus m divided by 7 plus m times g, and the time is 1 second. So what we are going to do is to write the Subat equation without v, because we don't need v and we don't have it, and we know is this one. So ut plus 1/2 8 squared. You know that you have these equations in your formula booklet, and we are going to substitute what we have. So displacement is 1 meter. I'm going to do here. Displacement is 2 meters, initial velocity is 0, so this bit is 0, and then I have 1/2 this expression times t squared, which is 1. So I have 1/2 3 minus m divided 7 plus m g. So from here, I just have to make m the subject to find the mass. Yeah, so it's just that. So I have 4. So I multiply this by 2, I have 4, 7 plus m is going to be 3 minus m g, so 28 plus 4m is 3g minus mg, and then I have 3mg, no. In one side I have 4m minus mg, so plus mg, m is going to be 3g minus 28, and from here m is 3g minus 28 divided by 4 plus g. And if you do this with a calculator, they don't ask us any particular rounding. This would be okay probably, but we can find the value with the calculator. Yeah, kilograms, and that's the answer. Yeah. Next thing is ignoring a resistance. Describe one assumption that you have made in your model. So one of the things that usually these questions tell you is that this mass doesn't reach the pulley. So we have assumed that, or we have assumed that this doesn't touch the floor, for example. So we can say either of them. So that this A mass, or the, how do they call it? The container doesn't reach the pulley. No, that's something that we can say. Container. Wait. And that's it. And that's all with this exam question.